Hi, I'm Steve Palumbi at Stanford University, and I work here at the Hopkins Marine Station in Monterey. But every once in a while, I get to work here in Palau. And what I want to do in the next few minutes is to tell you a little bit about the work we're doing with picric on heat-resistant corals all around the archipelago in Palau, how we're trying to use that to identify corals that might be best to be used in nurseries and restoration projects, and how that intersects with local communities all around Palau, and how it might be a tool for people to use in the future. So this is a view of our setup at picric in the back near the seawater system. Each of these is a coral reef stress tank that has chillers and heaters and lights. We will go out into the reefs using the boats at picric and the drivers and the really knowledgeable people that help us find the right reef environments, pull some fragments of those corals back, put them in these tanks, and then expose these different corals to a different set of environments. Now, we do it all at the same time in these tanks, then we can get a relative measure of how corals react to very standard conditions. And that's how we begin to ask, well, which corals are more sensitive to heat and which corals can survive ocean warming a little better. This is sort of some of the results that we tend to get. These are corals from one reef, that is the Luke's reefs on the eastern side, and this is a set of 5 corals or fragments from 5 different colonies. The top is when we've exposed those fragments to 30-degree temperatures, and the bottom is when we've taken those fragments of those same colonies and exposed them to 34 degrees for a few hours. That simulates a daytime low tide with the sun out, exposing these corals to high heat conditions. Now, this coral basically shows very little change when you expose it to 34 degrees. It's heat resistant to that degree, whereas heat sensitive. It has gone white. It's virtually lost all of its color. That means that it spit out the internal symbionts that give the coral flesh its color, and that provide the coral with a lot of the food that the coral has. So this is called a bleached coral, and bleached corals are what we often see when ocean warming happens all over the world and all over Palau. This would be an example of a relatively heat or bleaching resistant coral. This is a bleaching sensitive coral. So we've used this test at picric along with the staff there, including Victor Nestor, to look for heat resistant, bleaching resistant, and bleaching sensitive corals around the archipelago. So this is a view of where we've found heat resistant corals so far. Each of these red dots represents a heat we found on those reefs, and you can see 2 things from this. One is that they're pretty widespread. We find them almost everywhere where we look. But there are some places that have higher levels of these heat resistance, and that's one of the benefits of this broad mapping that we're able to do with the resources and boats and expertise at picric. For example, we can find this set of patch reefs in Amalik State that have a high degree of bleaching resistance. That's shown here. The same reefs that I showed in red dots are also shown there with their numbers. They've got colors around them that represent the different regions, and the same colors are here. Now, this red bar here represents the highest level of heat resistance that we've found anywhere around Palau. That's this set of reefs here on the western side. Now, if, for example, those particular, because they have a high degree of heat resistance, for example, protecting those from other harms might allow the protection of a larger set of heat-resistant corals than elsewhere. But we do find them in other places. Even the northern lagoon, which is relatively cooler, has a certain number of those heat-resistant corals. And there's some really intriguing offshore areas on the fore reef that have a high number of heat-resistant corals, higher than we would have thought. So there's still questions to be answered, and reefs to be explored. But this gives us a pretty good map of where to go to find heat-resistant corals around Palau. But we've taken this and tried to ask what good would it do to the community to have this information, and that's where we began working with a wonderful community out in Kaingal. And this shows some of our first collaborative efforts to grow corals in our restoration framework out with Kaingal. It's in a program that we've called the Strong Corals Initiative, because the idea is not only to grow corals in nurseries and restore them, but also to pick and choose to grow corals that might be a little more suited to ocean warming conditions because of future climate change. Essentially, to take the information we had from the heat-resistant maps and then turn that into a more successful product for restoration efforts. So this is Megan Morikawa, one of the grad students who was in my lab, and great folks up at Kaingal, in our first attempt to look at those heat-resistant corals. It's the first attempt to start a restoration type of project. This shows us some of the initial restoration efforts that we did. It turns out that these cement blocks that we made to put corals on were great for putting corals on. It works so well in the Kaingal Lagoon. So we have to shift the technology for that. Rebar and cable ties works really well for that. And what we're trying to do then is to essentially allow the community of Kaingal and others around Palau, if they so choose, to basically be the masters of this technology, do that in their own backyards. Just wanted to basically show you my sort of view of Pickwick is the bright light that it is, not only in Palau for the incredible staff it has, the dedication to science, the resources, the ability to do experiments and discover new things, but also the bright light that it has around the entire Pacific. It's one of the best places to go to do coral reef research almost anywhere. Researchers around the world flock to Pickwick to be able to use its resources there and to collaborate with the scientists there to discover new things. We've used the seawater system, we've used the molecular lab, we've used the freezers, we've used the storerooms, we've taken advantage of the incredible staff and the knowledge that's there in order to advance the work that we've been doing. But we've also found that the best kind of work is the collaborative work, where we have common goals, where we try to say, here's how we can add to what it is that Palau knows about its own reefs and how those reefs affect and help the people all over Palau. So, it's such a gorgeously beautiful place, and it's such a thrill to be there. It also allows us to feel like we're giving back to the community in a way that essentially takes the science that we're able to do and turns it into a product, turns it into something that is valuable not only to the scientific community but for folks all around Palau. So I just want to say thanks to Pickwick. Congratulations for your 20th anniversary. We're thrilled to be able to work there and work with you, and really want to make sure that what we're doing there in Palau is as exciting and useful to you as it possibly can be. So thanks and congratulations.